All this is Dr. Mobeen Sayed from drbeen.com. Today we have a very important and practical topic to discuss. So let us have a discussion. The topic is, what is the importance of hydration, that is the water that you drink, and the humidity in the air, that is the water present in the air around you, and maybe even then steam when it is needed. So let us have that discussion. The spilling the beans over here. Well hydrated person has better mucociliary clearance, and so they are protected better from respiratory infections. Similarly, humid air actually has more water in it, which allows the respiratory system to be more moist as well, which also provides us with the fluids in the respiratory system and allows us to clear the virus more easily. So that is the basic concept here. And now let's look at the mechanics of this and the study about this. The takeaway for you will be, please keep your relative humidity in your houses 40% or higher, considering for mold and other situations, considering your own respiratory workload as well. Some people have respiratory issues and they cannot have humid air. And then similarly, drink a lot of water, 8 glass or 15 glasses. We'll talk about that today as well. That is a very important, very practical concept to have, or a habit to have, especially for the respiratory infection, especially when the cold or flu season is coming. So let's discuss that. So we start with Dr. Bean over here. So this is drbeen.com. Now the article on which I am basing today's talk is this article. This is Fighting COVID-19 with Water. And so they have done a lot of good discussion over here. That is what I'm going to illustrate for you and discuss it. With that, there is another link that is from Mayo Clinic. And this is where we discuss how much water is necessary for all of us on daily basis. Again, it is important to consider your hypertension status, your cardiovascular status, your renal status, and any other respiratory issues before you start chugging too much water. But here, if you look at Mayo Clinic, 15.5 cups of water or 3.7 liters of water daily for men, and 11.5 cups or 2.7 liters of fluids daily for women. So that is the basic outcome, and let's start. So first of all, let me introduce Mr. Pussycat. This is actually Melody. So this cat is, her humans are Sydney D'Souza, Pearl, and Nishki, and she is one of the 5 cats, loves to hide in the behind these suitcases when somebody new arrives at the door. So cute cat here, and let's start our discussion. So fighting COVID-19 with water, that is a basic concept. So look, first of all, the transmission of respiratory viruses, transmission becomes better in cold, dry air. So one basic concept to keep in mind is that in the warm air, there is more water. Some people say that warm air holds more water vapor. That's technically incorrect. Air does not hold water vapors. It is just that the more temperature would allow the water vapor to move with more speed and not condense and not become water and drop to the floor. So the warm temperatures have more water vapor in the air moving about. On the other hand, the cold temperature, as we're going through the fall and now we're going to go to winter, cold air has the water vapors that are moving less fast, they're moving slowly, so they would merge with each other and they would condense and they'll become bigger droplets and they'll fall. So cold air is relatively less humid compared to warm air. That means we are coming into the cold air time where the respiratory infections will become easier to transmit. And then on top of that, in the cold time, in the cold season, we also have heat on, which also reduces the water vapor. So that is a double whammy that is going to occur. So please make sure, I've done this discussion in the past as well, that please make sure your environment is properly humidified to reduce the transmission of the virus. So warm air is inefficient for the virus transmission, respiratory virus transmissions. Cold air are better for the respiratory virus transmissions, and the mucosal barrier is inactivated as well. So not only just the air through which the virus is moving, but when we have dry air, we'll talk about that in a second, that causes the mucosal barrier, and I'll discuss what mucosal barrier is, that also becomes dry and becomes inefficient. So let's look at the mucosal barrier. So imagine this is our respiratory system. So we have lungs, and then here are the airways, correct? So external air, whatever it is, that air is going to pass through our airways, correct? It's going to go in and then it's going to come out. Our body tries to actually warm and moist the air that gets in. But again, if we are respiring fast, or if the air is too dry and cold, or it is too much heated with heaters or fireplaces, then it's going to be dry and our body cannot just compensate for it. So now imagine that this part of the respiratory epithelium is the surface of the respiratory system. Imagine these are a couple of cells over here. The cells that we have usually are ciliated. What does that mean? What that means is that on a cell, there are hair-like projections, which are called cilia. Cilia's function is to beat about and move the fluids around them and move the things in the fluid. For example, bacteria and viruses that are stuck in that fluid, they move that out as well. And usually from down here, from the lungs area towards the mouth, and then that becomes phlegm, which either we swallow or we spit it out. So what we can see is, if you focus in this part, the cilia are further glycated. And we talked about that glycation yesterday as well with the virus as well, that the spike protein of the virus has a coat of glycation or glucose around it. Similarly, our proteins that are present on the cell surface also have glucoses attached to them. That is called glycation. And this whole structure is called a glycocalyx, a jungle of glucose attached on the proteins. So imagine a tree, the tree trunk and the branches are proteins, and the leaves are glucoses. And this is called glycation. So here, if you see here, these are the cilia, and these cilia or hair-like structures on the cell are covered with glucose, which is called glycation. So I have zoomed in a little bit over here. So let's say this is one cilia, one hair on the epithelial cell. That hair is covered with glucose or glycans, and this is part of the glycocalyx. Then here is the important thing. There is one more thing in our respiratory system. So if I open my mouth, or if you look into your mouth and nose and the respiratory system, you would see it is all moist, right? So it is all wet. That wetness, imagine this block of water is that wetness. In that wetness, there is one more thing that is important for immunity, and that is called mucine. Mucine is nothing but, if you see here this little thing, there is this central core of a protein. So there is a protein branch. On that, these orangey looking things are glucoses that are attached to it. So this is called a mucine. Mucines are of two types. One are cell-attached mucin. So imagine my hair are mucin. So, and imagine if my head is a cell, then this mucin is connected to my head, although I'm losing hair, but this is attached to my head. Then what happens is, another thing is, if you look here, these are also mucine molecules. They are also protein branches that are coated with glucoses, but they are freely present in this wet surface. What is the objective of these present there? Many of the viruses and bacteria love to connect with our glucose structures. So these are decoys. These are fake cell surfaces we have made. So whatever is a cell surface that looks like this, we have made a fake surface by releasing the same mucin in the water. So when the virus comes in, let's say COVID-19, and it is now running around in the watery surface, it would see mucin, and it would say, yay, I'm going to connect with it. But that mucin itself is not connected anywhere to a cell surface. So now what happens is when we spit out that moisture or that phlegm, the virus would be spit out as well too. So that means we have secreted mucin and we have attached mucin. It is a secreted mucin that is really, really important because it would trap the viruses. And then as we remove this fluid, the virus will be removed as well. Then check one more thing here. So these are the two cells of the epithelial system. Look at this area. So these bone-looking structures are immunoglobulin A. Immunoglobulin A, once again, I continue to point at my mouth, the wet surfaces, that is mouth, nose, eyes, reproductive systems, GIT surfaces, the wet surfaces have immunoglobulin A or antibody A present in them as well. And that's function. The function of antibody A is to capture the pathogens that are arriving into our system. But this is only possible when that immunoglobulin has been produced. For example, if SARS-CoV-2 is what we're talking about, and I have never been infected with SARS-CoV-2 before, then I will not have the antibodies for SARS-CoV-2 in my moist surface. But once I am infected and once my B cells have started making antibodies, then they will make immunoglobulin A as well, which will now be always present in my moist surfaces. And that is when, if the virus arrives again, that immunoglobulin A is going to trap it. So how many things are now going to trap the virus? Over here, the immunoglobulin A, if present, the secreted mucin that is present, water itself is going to hold the virus as well. And then we are going to propel that water from downwards to above and kind of try to throw it out. So this is called mucociliary barrier, mucociliary barrier. And this is also called a mucociliary elevator. And what does that mean? Imagine from down here, from the lower part of the respiratory airways towards the upper part. What happens is our cells continue to beat their cilia upwards, and in that process, they move the fluids upward as well. And that fluid contains the viruses, and they are going to be thrown up. This is called mucociliary clearance. And this mechanism is called mucociliary escalator or elevator. So if you see here, these are the cells. These cells have glycocalyx on them. They also have mucines, those red spots here, and they have immunoglobulin A as well, which are the blue structures. So this is the mucociliary barrier. In this barrier, when the virus gets trapped, the cells of the barrier will beat upwards and move the virus upwards and then throw it out. Now, the importance of hydration. So today's takeaway is going to be importance of hydration and importance of humidity. Importance of hydration: if we do not drink enough water, then our cells cannot secrete enough mucus and enough secretions to make fluid thin so that it can easily move. So you may have actually seen that sometimes, that you have phlegm in the airway and you're trying to clear it, and it is just very sticky. The reason it is sticky is in a normal healthy person is because they are dehydrated. So if you see here, this cell has less water. So we have hydrated less, we have drank less water. So the mucous membrane here, the mucous barrier here, which is fluids, is really thick. In this thick mucous barrier, for the cilia to move becomes very difficult. This is like you put someone in mud and ask them to kind of move their hands, versus put them in water and ask them to move their hands or arms. It would be easier to do it in water compared to mud. So what is happening here is that this cell is at a disadvantage. It cannot clear the virus because the body is dehydrated and mucus is thick. On the other hand, if you look at this this cell has ample water with it. So it has been drinking, so we have been drinking water. It can secrete more of the mucus and more secretions. It is thin, it is easily going to be movable. So the importance of hydration becomes that our moist surfaces are more moist and we can be protected better. This protection is called innate immunity. Innate immunity is the immunity or defense of our system without caring for who is coming in. Just skin is innate immunity as well. Mucous membranes are innate immunity too. So we have better innate immunity if we are drinking more water. Continuing on, dry air. So now we're going to talk about humidity. So imagine if this is dry, if this is air and that air is dry. For example, it is cold or it has been heated with fireplaces and air moisture is less in it. Now, when that air goes in our body, in our respiratory system and ejects, it is going to take out the water vapors with it and make the mucosal barrier drier. So when the mucosal barrier is dry, if you can see here, why are these viruses kind of having a party now? Because they know that there is going to be a thinner layer of the fluid, plus that fluid is now going to be thick, and that is going to move less, which would allow the virus to kind of stick in that place easily and cause the infection easily. So they have done some studies and they found out that in the dry air, the infection by influenza is more compared to in the moist air. So the study said that if you increase relative humidity from 20% to 50%, that drops the mortality by influenza, it's not COVID, by influenza by a significant percentage. Similarly, there is more than 40% reduction in infection if the air is warm and humid. So dry air will cause infection, the chances of infection to be more. And then the expansion of the virus, that means the virus is going to stick there, it's going to go into the cell, and then it's going to divide or replicate or increase in number, and then it's going to go to the next cell and infect that, and so on. So that is called the viral expansion. So infection and expansion are increased. And of course, when the mucus layer is dried, it would flow less, so we cannot clear the pathogen easily. Continuing on, low humidity and the immunity. So in the low humidity, the mucous membrane will become thick. That would cause the ciliary movement to reduce. That would cause reduced virus removal. That would cause more chances for the virus to sit there and cause damage. That would also cause less repair of the respiratory system because virus is just sitting there hammering away at the cells and beating them up. And then that would also cause reduce interferon. Remember, we talked about it, that when a cell is infected with a virus, the cell is going to start releasing interferons, which are going to tell the neighboring cells to say, hey, bring your defenses up. There is something wrong. You become strong. And now when the fluidity of the mucous system is not good, then the secreted interferons are not going to be able to swim easily to the next cells and warn them. So the cells in the vicinity of infected cells will not be able to protect themselves well because the mucous system is thick and the interferon cannot swim easily. Similarly, when we are hydrated less, then we are producing less secretions from our cells, and the rest of the mechanism is the same. So less humidity and less hydration, if they both are less, we are in trouble. But they both can cause our immunity to go down. Then finally, relative humidity, hydration, steam, mucolytics. So how do we keep our mucosal barriers working? Number one, keep your humidity levels around you to 40% or higher. Number two, hydrate well. 15.5 cups or glasses per day for men, and 11.5 cups or glasses per day for women, or 3.7 liters for men and 2.7 liters for women daily water intake. Then if you need, take steam. And I remember that I had done a video in which I talked about will steam help you kill the virus? And I had said that steam will not help you kill the virus that is inside the cells. And many people made fun of me and left comments which were really funny. But anyways, that point still is there. Here, what I'm going to talk about is slightly different. If somehow the air is dry, or if somehow you are hydrating less, or for some reason your phlegm, for example, some pathology, your phlegm is thick, in that case, taking steam, which would give you a good dose of moisture to cause the fluidity, to increase the fluidity of the mucociliary barrier, that would actually be useful. It would not kill the virus, but it would allow you to clear the infected area or the bad mucosa out. So that would be useful. And finally, mucolytics. Mucolytics like bromhexin, mucolytics like hemostat mesylate and nefamostat and so on. So mucolytics can also help make the barrier more fluid and allow the barrier to move faster and clear the virus. So that is the discussion for today. The takeaway is here: drink plenty of water, keep humid air around you, and that is an important factor. And for influenza and other things, it actually reduces the mortality significantly, and it reduces the chances of infection significantly as well. There are no studies for COVID-19, but because COVID-19 is also a respiratory virus, it is a similar behavior with this as well. So this is the discussion for today. Thank you very much for joining. Please like, subscribe, and share. And there is a link for donations. If you would like to support my work, please, you can use that link to donate. So I would see you tomorrow.